This is poo, and what I want to do today is share my passion for poo with you, which might be quite difficult, but I think what you might find more fascinating is the way these small animals deal with poo. So this animal here has got a brain about the size of a grain of rice, and yet it can do things that you and I couldn't possibly entertain the idea of doing. And basically, it's all evolved to handle its food source, which is dung. So the question is, where do we start this story? And it seems appropriate to start at the end, because this is a waste product that comes out of other animals, but it still contains nutrients, and there are sufficient nutrients in there for dung beetles basically to make a living. And so dung beetles eat dung, and their larvae are also dung feeders. They are grown completely in a ball of dung. Within South Africa, we've got about 800 species of dung beetles. In Africa, we've got 2,000 species of dung beetles. And in the world, we have about 6,000 species of dung beetles. So according to dung beetles, dung is pretty good. But unless you're prepared to get dung under your fingernails and root through the dung itself, you'll never see 90% of the dung beetle species, because they go directly into the dung, straight down below it, and then they shuttle back and forth between the dung at the soil surface and a nest they make underground. So the question is how do they deal with this material? And most dung beetles actually wrap it into a package of some sort. 10% of the species actually make a ball. And this ball, they roll away from the dung source, usually bury it at a remote place away from the dung source, and they have a very particular behaviour by which they are able to roll their balls. So this is a very proud owner of a beautiful dung ball. You can see it's a male because he's got a little hair on the back of his leg there, and he's clearly very pleased about what he's sitting on there. And then he's about to become a victim of a vicious smash and grab. And this is a clear indication that this is a valuable resource. And so valuable resources have to be looked after and guarded in a particular way. And we think the reason they roll the balls away is because of this, because of the competition that is involved in getting hold of that dung. So this dung pat was actually, well, it was a dung pat 15 minutes before this photograph was taken, and we think it's the intense competition that makes the beetles so well adapted to rolling balls of dung. So what you've got to imagine here is this animal here moving across the African veldt. Its head is down, it's walking backwards. It's the most bizarre way to actually transport your food in any particular direction. And at the same time, it's got to deal with the heat. This is Africa. It's hot. So what I want to share with you now are some of the experiments that myself and my colleagues have used to investigate how dung beetles deal with these problems. So watch this beetle, and there's two things that I would like you to be aware of. The first is how it deals with this obstacle that we've put in its way. See, it does a little dance. And then it carries on in exactly the same direction that it took in the first place. Little dance, and then heads off in a particular direction. So clearly, this animal knows where it's going, and it knows where it wants to go. And that's a very, very important thing. Because if you think about it, you're at the dung pile, you've got this great big pie that you want to get away from everybody else, and the quickest way to do it is in a straight line. So we gave them some more tasks to deal with, and what we did here is we turned the world under their feet. And watch its response. So this animal has actually had the whole world turn under its feet. It's turned by 90 degrees, but it doesn't flinch. It knows exactly where it wants to go, and it heads off in that particular direction. So our next question then was, how are they doing this? What are they doing? And there was a cue that was available to us was that every now and then they climb on top of the ball and they take a look at the world around them. And what do you think they could be looking at as they climb on top of the ball? What are the obvious cues that this animal could use to direct its movement? And the most obvious one is to look at the sky. And so we thought, now what could they be looking at in the sky? And the obvious thing to look at is the sun. So, a classic experiment here, in that what we did is we moved the sun. What we're going to do now is shade the sun with a board and then move the sun with a mirror to a completely different position. And look at what the beetle does. It does a little double dance, and then it heads back in exactly the same direction it went in the first place. What happens now? So clearly they're looking at the sun. The sun is a very important cue in the sky for them. The thing is, the sun is not always available to you, because at sunset it disappears below the horizon. What is happening in the sky here is that there's a great big pattern of polarized light in the sky that you and I can't see. It's the way our eyes are built. But the sun is at the horizon over here, and we know that when the sun is at the horizon, say it's over on this side, there is a north-south, a huge pathway across the sky of polarized light that we can't see, but the beetles can see it. So, how do we test that? Well, that's easy. What we do is we get a great big polarization filter, pop the beetle underneath it, and the filter is at right angles to the polarization pattern of the sky. The beetle comes out from underneath the filter, and it does a right-hand turn, because it comes back under the sky that it was originally orientated to, and then reorientates itself back to the direction it was originally going in. So obviously, beetles can see polarized light. Okay, so what we've got so far is what are beetles doing? They're rolling balls. How are they doing it? Well, they're rolling them in a straight line. How are they maintaining it in a particular straight line? Well, they're looking at celestial cues in the sky, some of which you and I can't see. But how do they pick up those celestial cues? That was what was of interest to us next. And it was this particular little behavior, the dance, that we thought was important, because look, it takes a pause every now and then heads off in the direction that it wants to go in. So, what are they doing when they do this dance? How far can we push them before they will reorientate themselves? And in this experiment here, what we did was we forced them into a channel, and you can see he wasn't particularly forced into this particular channel, and we gradually displaced the beetle by 180 degrees until this individual ends up going in exactly the opposite direction that it wanted to go in the first place. And let's see what his reaction is, as he's headed through 90 degrees here, and now he's going to, when he ends up down here, he's going to be 180 degrees in the wrong direction, and see what his response is. Does a little dance, and turns around and heads back in. He knows exactly where he's going, he knows exactly what the problem is, and he knows exactly how to deal with it. And the dance is this transition behavior that allows them to reorientate themselves. So, that's the dance. But after spending many years sitting in the African bush, watching dung beetles on nice hot days, we noticed that there was another behavior associated with the dance behavior. Every now and then, when they climb on top of the ball, they wipe their face. And you see them do it again. Now we thought, now what could be going on here? But clearly the ground is very hot, and when the ground is hot, they dance more often. And when they do this particular dance, they wipe the bottom of their face. And we thought that it could be a thermoregulatory behavior. We thought that maybe what they're doing is trying to get off the hot soil and also spitting onto their face to cool their head down. So what we did was design a couple of arenas. One was hot, one was cold. We shaded this one, we left that one hot. And then what we did was we filmed them with a thermal camera. So what you're looking at here is a heat image of the system. And what you can see here emerging from the poo is a cool dung ball. So the truth is, if you look at the temperature over here, dung is cool. So All we're interested in here is comparing the temperature of the beetle against the background. So the background here is around about 50 degrees centigrade. The beetle itself and the ball are probably around about 30 to 35 degrees centigrade. So this is a great big ball of ice cream that this beetle is now transporting across the hot felt. It isn't climbing, it isn't dancing, because its body temperature is actually relatively low. It's about the same as yours and mine. And what's of interest here is that little brain is quite cool. But if we contrast now what happens in a hot environment, look at the temperature of the soil. It's up around 55 to 60 degrees centigrade. Watch how often the beetle dances. And look at its front legs. They're roaringly hot. So the ball leaves a little thermal shadow, and the beetle climbs on top of the ball and wipes its face. And all the time it's trying to cool itself down, we think, and avoid the hot sand that it's walking across. And what we did then was put little boots on these legs, because this was a way to test if the legs were involved in sensing the temperature of the soil. And if you look over here, with boots, they climb onto the ball far less often when they had no boots on. So we described these as cool boots. It was a dental compound that we used to make these boots. And we also cooled down the dung ball. So we were able to put the ball in the fridge, gave them a nice cool dung ball, and they climbed onto that ball far less often than when they had a hot ball. So this is called stilting. It's a thermal behavior that you and I do if we cross the beach. We jump onto a towel, somebody else's towel, sorry, I jumped onto your towel, and then you scuttle across onto somebody else's towel, and in that way you don't burn your feet. And that's exactly what the beetles are doing here. However, there's one more story I'd like to share with you, and that's this particular species. It's from a genus called Pachysoma. There are 13 species in the genus, and they have a particular behavior that I think you will find interesting. This is a dung beetle. Watch what he's doing. Can you spot the difference? They don't normally go this slowly, it's a slow motion. But it's walking forwards, and it's actually taking a pellet of dry dung with it. This is a different species in the same genus, but exactly the same foraging behavior. There's one more interesting aspect of this dung beetle's behavior that we found quite fascinating, and that's that it forages and provisions a nest. So watch this individual here, and what he's trying to do is set up a nest. And he doesn't like his first position, but he comes up with a second position, and about 50 minutes later, that nest is finished, and he heads off to forage and provision at a pile of dry dung pellets. And what I want you to notice is the outward path compared to the homeward path, and compare the two. And by and large, you'll see that the homeward path is far more direct than the outward path. On the outward path, he's always on the lookout for a new blob of dung. On the way home, he knows where home is and he wants to go straight to it. The important thing here is that this is not a one-way trip, as in most dung beetles. The trip here is repeated back and forth between a provisioning site and a nest site. And watch, you're going to see another South African crime taking place right now. And his neighbour steals one of his dung pellets. So, what we're looking at here is a behaviour called path integration. And what's taking place is that the beetle has got a home spot. It goes out on a convoluted path looking for food, and then when it finds food, it heads straight home. It knows exactly where its home is. Now, there's two ways it could be doing that, and we can test that by displacing the beetle to a new position when it's at the foraging site. If it's using landmarks, it will find its home. If it is using something called path integration, it will not find its home. It will arrive at the wrong spot. And what it's doing here, if it's using path integration, is it's counting its steps or measuring the distance out in this direction. It knows the bearing home, and it knows it should be in that direction. If you displace it, it ends up in the wrong place. So let's see what happens when we put this beetle to the test with a similar experiment. So here's our cunning experimenter. He displaces the beetle, and now we have to see what is going to take place. What we've got is a burrow. That's where the forage was. The forage has been displaced to a new position. If he's using landmark orientation, he should be able to find the burrow because he'll be able to recognize the landmarks around it. If he's using path integration, then it should end up in the wrong spot over here. So let's watch what happens when we put the beetle through the whole test. So there he is there. He's about to head home, and look what happens. Shame. It hasn't a clue. It starts to search for its house in the right distance away from the food, but it is clearly completely lost. So we know now that this animal uses path integration to find its way around, and the callous experimenter leaves at top left and leaves it. So what we're looking at here are a group of animals that use a compass, and they use the sun as a compass to find their way around, and they have some sort of system for measuring that distance. And we know that these species here actually count the steps. That's what they use as an odometer, a step counting system to find their way back home. We don't know yet what dung beetles use. So what have we learned from these animals with a brain that's the size of a grain of rice? Well, we know that they can roll balls in a straight line using celestial cues. We know that the dance behavior is an orientation behavior. It's also a thermoregulation behavior. And we also know that they use a path integration system for finding their way home. So for a small animal dealing with a fairly revolting substance, we can actually learn an awful lot from these things doing behaviors that you and I couldn't possibly do. Thank you.